Evaluating a postfix expression. Now, why would we want to evaluate a postfix expression? Well, in the last video, we discussed how when it comes to creating a calculator program, infix expressions are very complicated to deal with because they can't be processed in a linear, one token at a time manner. And here's what I mean by that. Suppose I have an expression that only deals with plus and minus operators. Well, in that case, evaluating it is simple. I just start at the front number. The first number is 5, so that's my initial answer. Then I process the next token, addition. That means we're going to add the next number we see. So we do that. Then I encounter minus. That means I will subtract the next number I see. So we do that. Then I encounter plus, which means I will add the next token I see. And it does that, giving me a final answer of 14. However, this becomes tricky when multiplication gets entered. Let's see what happens when I try this same process on multiplication. So we have 5, that's my initial answer. Then we encounter plus. Plus says to add the next number we encounter, so I do that. Then I encounter multiplication. That means to multiply by the next number we see, so we do that. But then that's where the mistake lies. According to the rules of PEMDAS, the multiplication should have occurred prior to the addition. Thus, this one token at a time approach failed once multiplication got introduced, and it would all get even worse if we brought parentheses into the picture. So in summary, infix expressions are complicated because they can't be dealt with in a linear, one token at a time manner. Postfix expressions, however, can, and here's how. So here's my first postfix expression. I insert these tokens into an input queue of tokens in the order that they appear in the expression. My output will be a queue of tokens, and I'll use a stack called numStack to help me during this process. I call it numStack because that is short for number stack. The numbers will be going in and out of this stack. So the first token is 20, put it on numStack. 8's a number, put it on numStack. Plus is a binary operator. So what we're going to do now is take the top two values on numStack and apply the operator to those two values. Then we're going to push the result onto the numStack. After we do that, we no longer need the operator. Next token, 3 is a number, put it on the numStack. Now we have minus. Apply minus to the top two values. We get 25. Throw away the minus. Now we're at 10. Move 10 to the number stack. Then we encounter plus. Apply to the top two values of the stack. We get 35. The input is empty. Thus our final result is 35. And when we check ourselves, this was the original infix expression. When we check it, 20 plus 8 is 28. Minus 3 is 25. Plus 10 is 35. Thus, we got the correct answer. All right, here's the next postfix expression. 50 is a number, put it on the number stack. 20 is a number, onto the number stack. 2 is a number, onto the number stack. Multiplication, operator, pop the top two values, apply the binary operator, and we get 40. Get rid of the operator, now we have 4, put it on the number stack. Now we got division. If we apply that to the top two numbers, 40 divided by 4, we get 10. Throw away the division. Now we got plus. Apply that to the top two numbers. Now we got 60. Input is empty, so our final answer is 60. All right, next expression. 50 is a number, onto the number stack. 5 is a number, onto the number stack. 2 is a number, onto the number stack. Hat operator, the exponent operator. That's a binary operator. Applied to the top two values in the stack. 5 squared, we get 25. Get rid of the operator. Now we got plus. Apply that to the top two operators. And we get 75. Throw away the plus. 15 is a number. Put it on the stack. Minus is an operator. Apply it to the top two operators. And we get 60. The input is empty, so 60 will be our final answer. 20 is a number, put it onto the number stack. 5 is a number, onto the num stack. 3 is a number, onto the num stack. Minus is an operator, apply it to the top two numbers in the stack, and we get 2. Next, we got another operator, multiplication. Apply that to the current top two numbers, we get 40. 4 is a number, onto the num stack. Division, apply it to the top two numbers, we get 10. Input is empty, final answer is 10. Alright, final expression. 6 is a number, onto the num stack. 4 is a number, onto the num stack. 3 is a number, onto the num stack. 2 is a number, onto the num stack. Now we got an operator, multiplication. Apply that to the top two values, 3 and 2, and we get 6. Throw it away. Now we got plus. Apply the plus to the current top two numbers, and we get 10. Throw it away. Multiplication. Apply that to the top two numbers, and we get 60. Throw it away. 5 is a number, put it on the num stack. Minus is an operator, apply it to the top two numbers, and we get 55. So 55 would be our final answer. So, in summary, if the token, as you process each token one at a time, if the token is a number, then simply push that number onto the num stack. If the token is an operator, then pop the top two values of the num stack, apply the binary operator to those two values, then push the result onto the stack. Once the input is empty, the final stack value will be your result.